Hello everyone, welcome to my programming club. Today we will be solving the problems of weekly contest 362. So let's quickly move to the first problem of the contest. And the first problem of the contest name is points that intersect with cars. So you are given a zero index to the integer array nums representing the coordinates of car parking on a number line. For any index I, nums of I is of the form start and end, where start represents the starting point of the ith car and end represents the ending point of the ith car. You have to return the number of integer points on the line that are covered with any part of the car. So let's try to solve this problem. So let's say this is the number line given to you. Instead of cars, let's say we are for all the cards are in the form of an interval start and end. Let's say these are the points given. Now for let's say cards are given like this. And let's further extend this number line. As you can see, these points are not covered by any of the card. Rest all are covered. So if you see which point is covered by how many number of cards are covering a point, how many number of cards covering a point, number line. This point is being zero is being covered. Let's extend this to zero. Zero is being covered by only one. One is also being covered by only one interval, which is this interval. Now two is being covered by two. This one and this one. So two. Three is being covered by only one. Similarly, four by only one. Five also by only one. These are covered by only zero intervals. So if I give you this array, then you can easily find out how many number of points are there that are at least covered by one car. So what you will do, you will if you know the size of this array, let's call this the size sz. Let's call this array prefix, and length is sz or size. So number of your answer will be number of points covered by at least one car. Size minus number of zeros in array. Number of zeros in array. Now the question arises uh, that how you will be getting this array generate, how you will be able to generate this array. So this is nothing but a standard prefix sum implementation. What we will do, uh, let's say an interval is given to you 4, 3. Let me move to a new slide. Let me mark the points 1, 2, 3, and 5. Let's say instead of 4 comma 3, it was 2 to 4. This is the interval of the car given to you. What you will do, initially all the entries in your array will be 0. This is the prefix array. So at 2, you will, let's say you put a flag here, and at 4, this is the end point. At endpoint plus 1, you put a negative flag. This is a positive flag. This is a negative flag. Let's denote it by some other color. It denotes addition of plus 1. It denotes subtraction of 1. So now this value will become 0, will become 1, and this value will become -1. If starting from this point, you add the previous values, one previous value to the current value, and keep on moving forward, then you will be having something like this. Initial two values will be 0. It will be 1. Now this 3 is initially 0. 3 plus previous value, which is 1, will be 1. Now 3 is 1. So 4 plus previous value of 3 will be 1. Now this 5 is -1 plus previous value of 4, which is 1, it will be 0. So as you can see, you are able to generate all the points that will be covered by this particular interval. All points covered by this car. So you can easily return how many number of points are being covered. The total size was 6 minus number of zeros 3 equal to 3. 3 points are being covered. So this is the logic. Let's move towards the implementation. It is essentially the same thing that we will be doing. Since the length of the array is of 100, order 100, and starting and ending point will have maximum value of 100. So we are taking 200 value. It will be sufficient enough to accommodate all the points. Size 200 will be sufficient to get all the points. Pardon me if some spelling is incorrect. I hope it does not affect your understanding of the approach. So what you will be doing for each interval representing car, you will mark the starting and ending points of its contribution. On number line. These starting and ending points of contribution are nothing but flags. These flags, these are, I am calling these points of contribution. So once you are done with it, you will generate the array, generate the prefix sum array. So as the name suggests, prefix sum is carrying sum from the previous numbers. So prefix sum array will be generated, and then you will count the number of zeros. Prefix sum array in the prefix sum array, and then you will return the number of points that are being covered by at least one car. Then you will return the number of points that are covered by at least one car. So that's pretty much it for the implementation. Let's try to submit it once. As you can see, it's getting accepted. So let's move towards the second problem. Second problem's name is determine if a cell is reachable at a given time. So you are given the coordinates of starting and ending points. Let me explain it in my own words. There will be a starting point, and let's call this X. And there will be an ending point. Let's call this Y. So you will be given coordinates of starting point and coordinates of ending point. Let's denote it by E. So these two things will be given to you, and you are being told that for a, let's say you are in this cell, then you are allowed to move in for 8 directions, these directions. These directions you are allowed to move. So it will be, let's say the present coordinates are x comma y, then it will be x plus 1 y, x minus 1 y, xy minus 1, xy plus 1, and similarly for these also, x plus 1, y minus 1, x minus 1, y plus 1, x plus 1, y plus 1, and similarly for this also, it will be x minus 1, y plus 1, it will be minus 1. Pardon me, I have marked the coordinates of some point, some direction incorrect. I hope you are able to get what I am trying to tell you. So these are the directions that you will be allowed to move. You have to tell you will be given t number of moves. You have to tell whether you can reach start point to end point in exactly he moves. So this is what you have to tell. Now, how you will be solving this problem? First of all, let's consider a scenario. Let's say your starting point is this starting point, and your ending point is this ending point. So, if you are allowed to move, and one thing I forgot to mention it, you can enter any cell any number of times. It's mentioned in the problem statement. You can visit the same cell several times. So these are the things that will be given to you. Let's say this is the starting point and this is the ending point. What is the shortest way to reach this starting point to ending point? It will be this. Now, if you do not take this path or this direction, you can go something like this, or you can go something like this. Here you can see that it will take you one move. If you move between two adjacent cells, then it will be considered one move. So this yellow direction will take you two moves. Yellow path, no direction, and this red path will take you two moves. So you can easily see that a diagonal is the shortest, or will save us some moves. So diagonal moving will save some moves. Also, let's say your E was not here, endpoint was not here, and it was somewhere else. Let's say instead of this position, it was situated here, which is not exactly diagonally opposite to S. Then shortest path will be 1, 2, and 3. If you try to take any another path, let's say this one, it is costing you more number of moves. Let's try to take another one. Let's say this one. It is again costing you more number of moves. Let's say you decide to take this one. Let me change. I have run out of colors actually. Let's continue with this. As you can see, it's taking you more number of moves. So this is indeed the shortest one possible. So you are able to observe that when such a situation arises, uh, basically some distance you will travel diagonally, and some distance you will travel horizontally or vertically, plus some distance horizontally or vertically. So if let's say you are covering this whole distance in 1 second, you are allowed to take one move, and you are given t seconds exactly to reach your destination or ending point. Or uh, let me see. Yeah, each second you must move to any of the adjacent cells and return true if you can reach the ending cell exactly t seconds or false otherwise. So let's say, and it is true that you can stay in a cell uh, you can enter in a cell any number of times. Then if let's say you cover this whole distance in this whole distance, both of these in x seconds, then if x is lesser than or equal to t seconds, you will return true, because anyways you can increase. If let's say x is lesser than t, then you can increase your time by revisiting cells. That's the case. You will simply be checking for this condition once you have calculated this distance, and two edge cases will be there. If let's say the starting point and the ending point is are on the same cell, and t is given to be uh, let's say 1, then in that case you will return false. So t should at least be greater than 1, because initially you will be at your starting point at the 0th second, or t should either be greater than equal to 1, greater than 1, or t can be equal to 0. At t is equal to 0th second, you can be present at this kind of cell where starting and ending points are the same. So these are two edge cases. Rest I have explained. Let's move towards the implementation. So uh, together distance together, that x and diagonal distance that you will be moving, which is nothing but the absolute difference of minimum of absolute difference of x and y coordinates, and the leftover distance that you will be moving it will be either horizontal or vertical. So based upon that, you will be taking the leftover distance will be either vertical or horizontal, and at last you will add the total list. You will calculate the total distance, and you will return whether the total distance is lesser than or equal to t, since you will be moving 1 unit of distance in 1 second. Now let's try to submit it once. As you can see, it's getting accepted. So let's quickly move to the third problem of the contest. So the third problem's name is minimum moves to spread stones over a grid. So you will be given a 2D integer array representing a grid of fixed size, which is 3, 3, 3 cross 3, representing the number of stones in each cell. The grid contains exactly 9 stones. There can be multiple stones in a single cell. So this kind of grid will be given to you. So as you can see, uh, a grid can contain multiple stones or it can contain 0 stones. So in one move, you can move a single stone from its current cell to any other cell if the two cells share a side, or you can say uh, those two cells are adjacent. In that case, you will be able to move stone from that cell. Uh, Let me quickly take another slide to make you understand what our adjacent cell is meant here. So let's consider this cell. Adjacent cell for this one will be these two. These are sharing a side with this cell. So I hope you are able to understand what adjacent cell is. Now what you are asked to return is you have to return the minimum number of moves required to place one stone in each cell. At least one stone should be present in each cell. So if we check for this particular case, let's copy it. So for this index, for this cell, what you can do is you can borrow from this one. It will require you 1, 2, and 3 moves. You cannot borrow from this one and this one or this one, because it will result zero empty cell. You can say there will not be any stone in there. So you can only carry from the cells only which have more than one stone. And basically you have to take the Manhattan distance only, minimum distance that will be there. Let's say what is the Manhattan distance? Let's say this is x1 y1 and this is x2 y2. Manhattan distance will be absolute value of x1 minus x2 plus absolute value of y1 minus y2, which is nothing but how far 2 points are vertically plus horizontally. So this will be your minimum distance. And how you will be solving this problem? What you will do is, let's have a look at the constraints. Since the constraints here are pretty low, the number of cells in the grid is 9 only. It is fixed. So what you will do, you will store the coordinates of 0 containing cell. X and Y coordinates. and you will store the coordinates of non-zero cell. Non-zero cells which are having more than one stone. So once you have stored the coordinates, let's say you have stored the coordinates in zeros. This is a array or say vector that you will be storing the coordinates in, and let's call this ones. This is also array and or vector, depending upon the language which you are using to implement. So once you are done with it, you can use backtracking. Uh, for each uh, coordinate present in zeros array, you will consider all of its options, and whichever configuration gives you minimum moves, you will choose that configuration. And simply you will return minimum moves. So let's have a look at the implementation of the approach. What you will do is initially you will be initializing your minimum moves to the maximum integer value. Then what you will do is you will store the coordinates of zero containing cells and cells with more than one stone. So these two will be used to store the coordinates. So after you have stored the coordinates, you will backtrack. You will implement a backtracking solution. For each of the in for each of zero for each zero containing cell, You will explore all the options it is having in a depth wise manner, and then backtrack to explore further options. Uh, if you decide to take a stone from a cell, then you will decrement the number of stones in that cell. And once you backtrack to this position, this point again, once you decide to backtrack, then you will simply return the number of stones present in the cell to its original value. And this is how you will be checking. Once you have once you have filled all the zeros, once you have filled the all the cells with at least one stone, then you will update the minimum number of moves, and at last you will return the minimum number of moves. So that's pretty much it for the implementation part. Let's try to submit it once. As you can see, it's getting accepted. So that's all from my side. For the fourth problem, I was not able to solve it in a given time which the contest usually provides us. It is 1 hour 30 minutes. So I will be making a separate video on this particular problem when I will upload it. So thanks for watching. If you are still having any doubts in these three solutions or approaches, you can say, then please feel free to ask them in the comment section. And if by mistake some error is being done on my side on the ex explaining part, then if it's not a major hurdle your understanding, then please ignore it. Uh, some spelling mistake or some mistake in taking an example or something like that. Uh, rest all is fine. And if you are having any suggestions or some constructive criticism, then you are most welcome. Please give suggestions and in the comment section and ask your doubts. So thank you for watching, and yeah, thanks.